Good morning, students. Today we are talking about probability. I'm wearing my unicorn costume. What's the probability that will ever happen again? All right, so let's get started. We have discussed probability before. Probability describes how likely it is an event occurs in an experiment. So probabilities are fractions. Here we go. We have a typical dot cube. It has 6 faces marked with dots representing 1, 2, 3, 4, 5, and 6. So we could do an experiment, roll a dot cube and record the amount of times an upturned face comes up. Each time the possibility of rolling a 1 would be 1/6, of rolling a 2 is 1/6, of rolling a 3 is 1/6, and so forth, and so on. So when we have our 6 different sides, so 6 of 6 is equal to 1 whole dot cube. So we can add probabilities in order to determine the likelihood of one of a certain collection of outcomes. So if we're talking about even numbers, our options for even numbers on the dot cube are 2, 4, and 6. So we can add that 1/6 up, 1/6 plus 1/6 plus 1/6, and we get 3/6, which is half of the times of rolling a dot cube you would get even numbers, which means the other half you would get odd numbers. So what is the probability that the upturned face is either 1 or 6? So 1 or 6. So when we're looking at that, we have 2 different options, correct? So 2/6. 2 outcomes out of 6. All right, so you are 5th graders, and therefore I always say reduce your fractions. So I could divide both of these by 2. Here. Divide them both by 2. 2 goes into 2 once, 2 goes into 6 3 times, and we have 1/3. Next, what is the probability that the upturned face is less than 5? Well, guess what? We have 4 different options for that. 1, 2, 3, 4. So our fraction will be 4/6. And once again, you are 5th graders. You need to reduce, reduce, reduce. 2 goes into 4 2 times. 2 goes into 6 3 times. So 2/3 of the time, when you roll the dot cube, you will get 1 through 4. All right, let's move to the next page. Page 642. So if we roll our dot cube repeatedly and we keep trying and trying, we roll it 24 times, 1/6 of the time. All right, we would roll, how many times would we roll a 2? So the way I like to write that out would be 1/6 of 24 times. And as we know, we would do the math by dividing 24 by 6, and we would get 4 times. We would roll a 2. All right, on the next one, because 3 faces show even numbers, we would predict that we would roll an even number 3 of 4 times, which would be half of the time, right? Now these are only guesses, and you can't really predict the outcome, but you can get close. All right? All right, so if a standard dot cube is rolled 60 times, so that would be 1/6 of 60 is how I like to think about it. So 6 goes into 60 how many times? So 60 divided by 6 would be 6 goes into 6 once. Subtract, bring down, 0, 0. 6 goes into 0, 0 times. So we roll the dot cube 60 times. The chance that we would get 1 would be about 10 times. All right, now if the standard dot cube is rolled 60 times, and how many times could we get either a 1 or a 6? So that is 2/6 because we have two different numbers, two different options of the 6. All right, 2/6 of 60. Now guess what? I can just use my last answer to help me or guide me, correct? Because I know that I will just multiply my 10 times 2, right? So 2/6 of 60 would be 20 times. All right, now guess what? When I look at this, I can do my 2/6 or my 1/6 of 60, which is 10. And then I know that I need to either double it or multiply it times 2. All right, next, we are going on to do a little experiment. Now in the experiment, I already rolled the dot cube because I thought you probably didn't want to sit there and watch me roll a dot cube for very long. So here we go. When I rolled it, as you can see, there should have been 4 would have been the common number. Well, we got close, but number 4 was a big one for me. I rolled it 7 times. 3 was a big one. So it didn't come out exactly as the outcomes show that they may, but here we go. I rolled a 1 3 times. I rolled a 2 3 times. I rolled a 3 6 times. I rolled a 4 7 times. I rolled a 5 3 times, and I rolled a 6 2 times. So let's answer our questions. Which of the 6 outcomes occurred more frequently than you would have guessed? Well, the 4, right? How many times was the upturned face even? So this is interesting. I went back to here, and even. I had 3, 7, 10, plus 2 for 6, that's 12. So 12 times the upturned face was an even number, which is half of the 24, which estimating or predicting probability, that is more accurate. So based on the table, what would my next roll be? Since I didn't have very many 6s, I predict my next roll would have been a 6. If you have a dot cube, you can roll it and see what would happen. All right. Next, we are going to talk about probability with a spinner. Now, as you look at the spinner, it is divided up into 3 different regions, but they are not equal regions. So we are going to do a relative frequency table. That means we're not going to be exact. Serena constructed a spinner with her 3 regions. All right, she did not have a definite plan, obviously, by the size of each region. So to estimate the fraction of the whole, she spins the spinner 50 times. She presents the results in a relative frequency table, which means that it isn't going to be exact, but she's going to try to determine what the size is of the table. And we will look and see if the information looks correct. So since 17 of 50 spins stopped on 1, Serena estimates the probability of 1 as an outcome, 17/50ths. All right, so she assumes that her circle, number 1 in her circle, takes up about 17/50ths. Now, similarly, she spins the probability of 2 as 28/50ths, which, as you look at this is a little bit smaller than half. This is a little bit, 1 is a little bit bigger, larger than half, correct? All right, so she estimates the probability of 3 as 5/50ths. All right, so she can see that 5/50ths, which, as we see, the 3 is probably less than half of the 1. All right, so because 28/50ths is greater than 17/50ths, outcome 2 seems more likely than outcome 1. Because 17/50ths is greater than 5/50ths, outcome 1 seems more likely than outcome 3. If you just looked at the spinner and not at the table, would these statements make sense to you? And yes, we were just discussing that. Because this is less than half, 1 is almost about 2/3 of the 2. Almost, not quite. And then 3 is less than half of the 1. All right, so do you think that 28/50 overestimates the true probability of stopping on 2 or underestimates? Well, guess what? I am going to say that it overestimates, because the 1, spinning a 1 was 17/50. Spinning a 2 was 28/50. This is not quite half of the circle, and so I'm going to say that they are overestimating. They're close, but it's an overestimation. All right, now we are going to skip activity 2. It takes partners, and as much as I wish we could partner up today, we just can't. All right, so we are moving on to, if an experiment has n outcome and they are equally likely, then the probability, each has a probability of 1n. So let's say if we flip a coin, which has 2 likely outcomes, all right, the probability of the coin landing heads up is half. The probability of it landing tails is half. All right, so suppose we write each letter of the alphabet on an identical tile and then turn the tiles over. If we select one tile at random, what is the probability the tile is the letter E? Think about this. How many letters are in the alphabet? Oh, you don't have the alphabet in the classroom to count, but there are 26 letters in the alphabet. What is the probability that you are going to pull an E? 1/26, correct? So, what is the probability that the tile is a vowel? How many? So, think about how many vowels there are. Remember, vowels, A, E, I, O, U. So, there are 5 vowels out of 26. Now, I didn't use the sometimes why. All right, and the last question. What is the probability that the tile is a consonant? Well, guess what? I don't have to sit and count the consonants. I just take my 26 and I subtract 5, correct? And that is 21/26. All right, next we have a bag that contains 20 colored tiles that are red, yellow, or green. A tile was picked from the bag and replaced 30 times. The table shows how many times each color was picked. So red was picked 12 times. Yellow was picked 3 times. And green was picked 15 times. All right, so use the outcomes shown in the table to predict how many tiles of each color are in the bag. So a green tile was chosen half of the times, right? Green was chosen because there are 30 times. So a green tile was chosen half of the times. All right. So that tells us about 10 of the tiles should be green because half of 20 is 10, right? So 10 of the tiles should be green. I'm sorry, that's kind of messy. All right. Then we have a yellow tile was chosen 1/10 of the time because 3 of 30 is 1/10, right? All right, so that tells us about 2 tiles should be yellow, correct? 2 of the tiles should be yellow. And last but not least, we have a red tile is chosen 2/5 of the time. 2/5 of the time. So about 8 of the tiles should be red. All right. So when we look at this, I want you to think about this in a couple of different ways, okay? I'm going to slide over to this side. So our fraction, 15 of 30, right? That equals half, right? Our fraction, 3 of 30, that we would reduce, divide by 3, right? And get 1/10. All right, and then we have 12 of 30, right? 12 of 30. So, what goes into both of these numbers? We can divide both of these by 6, correct? Because we have to reduce this 12 of 30. And 6 goes into 12 2 times, 6 goes into 30 5 times. And there we go. So, when you think about how many tiles of each, all right, half of the tiles were green, all right? All right. 1/10 were yellow, and 2/5 were red. All right. So, probability. Guess what? No homework tonight. Have a great night.